Tuition Mobile, quality e-learning experience on the go.
You're welcome to today's class. Our topic for today is titled Logical Reasoning. Logic is the study of the way in which people reason with the primary aim of knowing and applying the principle of valid reasoning. Alright, there are two types of logic. The two types of logic we have are we have the traditional one. We have traditional logic, and two, we have mathematical logic. Okay, now traditional logic is associated with the use of forms of logic. These are the forms of logic frequently used ordinarily in just ordinary logic reasoning. But when we talk about mathematical logic, we talk about the use of reasoning. The use of reasoning, they are used to test the correctness of a chain of reasoning by examining the statements which make up the chain. They are used to check the correctness of a chain of reasoning by examining the statements which make up the chain. Reasoning and statements. You can see from our definition we have come up with two more words: reasoning and statement. Alright, reasoning may be described as a process in which a collection of facts and ideas are considered with a view of bringing out the relations or connections which exist between them. Reasoning has to do with a collection of facts and ideas and our intention here is to bring out the relationship that connects these facts together. Alright, what about statement? We'll see that after we make some examples about reasoning. Alright, over to the next slide. Now remember, we're still talking about reasoning. Just like we said, it is comprised of facts and ideas, and then for which we look for relationships between them, facts and ideas. Okay, reasoning consists of a number of statements which express the facts or ideas that are being considered. Let's take for example we shall consider the following arguments. Sorry, this should be consider the following argument. Okay, the first argument goes this way. Argument one. All integers are real numbers. And then if 5 is an integer, therefore all we are saying is that 5 is a real number. Right, 5 is an integer, so therefore I can write that in full. Therefore 5 is a real number. Alright, that's understandable. You can see the facts and the ideas. You see, statements follow up, and then one statement, another idea is established from one statement. There are connections between statements considered here. Okay, that is why we call them reasoning. reasoning are used to make up. All right, let's continue. The second argument we want to talk about today is argument 2. All right, let's see what that has to say. Every hardworking person is well paid. All the teachers in Lagos State are hardworking. Lawal is a teacher in Lagos State, therefore Lawal is well paid. Okay, did you see the logical reasoning behind the statement? The first statement follows, the second statement follows, and has a connection with the first statement, and then from the first statement the second statement follows, the third statement follows, and then a conclusion from the last statement. We are saying here the principal line of reasoning here is that every hardworking person is well paid. Okay, every hardworking person is well paid. Okay, and then all the teachers in Lagos State is another reasoning. All the teachers in Lagos State, are hardworking. They all are hardworking, and so therefore Lawal, a teacher in Lagos State, will also be hardworking, since all the teachers in Lagos State are hardworking. Lawal, a teacher in Lagos State, then means that Lawal is hardworking, and it also follows that Lawal is well paid. So therefore we can conclude based on these ideas that therefore Lawal is well paid. Okay, you can see how the flow of reasoning moves from the first statement to the second statement to the third statement and then to the last statement. Okay, all right, I want us to see that both arguments can be seen as containing a number of statements, in each of them one sentence. Okay, I mean the last statement follows from the other, such that if each of the other statements are true, then this one statement is also true. I hope you understand this. All right, we should also note that information expressed in the first statement is called facts. Said that every hardworking person is well paid, and then every hardworking person being the first statement is called a fact. Okay, for which the second statement could be true or it could be false. Based on the fact that every hardworking person is well paid, then it follows that the second statement could be true or could also be false. All right, here leads us to a subtitle of what we call a simple statement. A simple statement. Let us find out what a simple statement is. A simple statement. Okay, you see, logical reasoning is one of those tough topics that has to do with more of theories than practicals. So I just want to believe that somehow along the line you will grab this. All right, a simple statement. A simple statement is defined as a sentence which is either true or false. It is also called a proposition. So that means a simple statement could be either true, it could be either true or false. All right, it is also called a proposition. A simple statement is also called a proposition. A simple statement is also called a proposition. A proposition. All right. Okay. Simple statements are of four forms. There are four forms of simple statement. The four forms of simple statements are: they are subjectless. Okay, They are one subjectless. Okay, in subjectless, it consists of a subject. Okay. All right. Okay, that is, it consists of a subject. And number two form is the one we call the subject predicate, the subject to predicate, the subject to predicate. All right, these two consists of subjects, consists of a subject and a predicate. I think you must have heard this in your English language, a predicate. All right, and then the third form of simple statement is the class membership. The class membership. The class membership. Alright, the class membership states that a certain set is a part of another set. Okay, it is used to state that a certain state, not a certain state, a certain sect. Okay, it could be set of objects. Okay, a certain set is a part of another set, just like we had in the first illustration that Lawal works in Lagos State, and every teacher in Lagos State is hardworking. So if Lawal resides in Lagos State and he's a teacher in Lagos State, then it means that we'll continue. We have the fourth form of simple statement. The fourth form of simple statement, number 4, the one we call the relational. The relational. Okay, what does it do? It expresses a relation between two terms, two or more terms. Okay, it expresses a relation between two or more terms. Okay, I can simply write expresses a relation between terms. Okay, and that is that. All right, so but I'll be making an example of the last two forms of simple statement, just like I said previously. In that of class membership, we can as well use some other example. Okay, we can use some other example for tray. Okay, making examples for tray. Example for tray. Okay, that is the one we call the class membership. The class membership. Okay, an example here is that all judges of the High Court are workers who should be paid highly. All judges of the High Court are workers who should be paid highly. Okay, good. It means that if anybody in this class works with a High Court, then it means he earns a reasonable amount of money. Okay, so you can see that all judges defines a set or a group. Okay, so that's what we're talking about. We said that it states that a certain set is a part of another set. And then an example of the relational form of simple statement is that hexagons have more sides than rectangles. Okay, now you can see that here expresses a relationship between two terms. All right, I can quickly write that. So we shall be making an example of the fourth form of simple statement. The fourth form of simple statement, we said number 4 is relational statements. Relational, and this we say that it expresses a relation between terms. It expresses relations between terms. And so an example of the relational statement is this example, where we can say that a hexagon has more sides than rectangles. So here you can see that it expresses relationship between two objects between two terms, that is the rectangle and the polygon. Okay, and so one thing we have to note here is this. We have to note that a statement must either be true or not true. You should note that a statement must either be true. It must either be true or not true. Sorry, a statement, I can take that again. A statement must either be true or false and not true. The statement must be either be true or false and not true. So every statement has two properties. Property 1, it is true. Property 2, it is false. Alright, I want us to talk about one other term for this our lectures, what we call negation. A statement which is modified by the use of word is called negation. There is a particular word that is used to note negation, and it is called the word not. Okay, and so we say negation is a statement modified by the use of word. By the use of word. All right. Which word are we talking about? We are talking about the word not. Okay. Suppose we have an example. Okay. Let me make some more explanation about this. Remember, I told you this course may seem to be difficult, but with time you will get to understand. It is this way because it is more of logical reasoning. It is more of theoretical than practical, and so sometimes I will need to go back and make some explanations. It's called the negation of the original statement. When this word takes part in a sentence, okay, we say that the negation of the original statement has happened is as good as saying the opposite of what you intend saying has taken place. For instance, we can take an example as this. We can take an example as this. Okay, we shall determine the truth values of the following statement. Okay, let's try to determine the truth values of this following statement. All right, the triangle has 4 vertices. The triangle has 4 vertices. And so the negation of this statement could be, in negation you can say that the triangle does not have 4 vertices. Okay, you can see the negation at this point. Okay, playing it through, taking you back to the opposite side or the opposite implication of the first statement. All right, let's talk about compound statements. I want us to talk about compound statement. Let's see what that means. Compound statement. Remember, we first discussed about simple statement. Let's talk of something new. Compound statement. Okay, a compound statement is a combination of a number of statements which is obtained by applying certain words or group of words. Okay, you can say a compound statement is a combination of a number of statements. Sorry, okay, this is my off, but let me do this better. Combination is a combination of number of statements. Okay, which means more than one statement. Number of statements, can make it plural statements, which is obtained by applying a certain word, which is obtained by applying a certain word. Okay, this is my word. All right, and so there are by applying a certain word or group of words. Okay, just like I said, a combination of number of statements by applying a certain word or group of words. It could be one word or group of words. All right, just like in our negation, you find out that negation is also a form of what helps to conjoin compound statements together. Okay, but let us talk about what we call those group of words that help us to combine a number of statements to find a compound statement. We call them sentential connective. Sentential connective. Sentential connective. So what are sentential connectives? They are words or group of words used to join compound statements, used to formulate compound statements. A group of words, a group of words used to formulate compound statements. All right, there are four connectives or sentential connective. We have 4 of them. We have four types of sentential connectives. Alright, and they include as follows. We have number one, the one we call the and. Number two, we call the or. Then number three, the one we call the if then. Alright, and then number four is the one we call the if and only if and only if. Alright, let's talk about something else we call the prime statements. They are statements or combination of statements combined to give a compound statement. Okay, they are combination of statements. Right, they are combination of statements that results into compound statements. Alright, we shall take examples of statements of this form. Examples. And the number one example we have here is the expression that x plus 2 arc squared is a perfect square. And x plus 2 squared is equal to 25 when x is equal to 3. Alright, our interest here is on this, the sentential connective z and the sentential connective, and that's where we have our interest in. And for the second example, example 2, either Adamu works hard, at his books, or he will fail the examination, or he will fail the examination. Alright, if you observe very well, you find that where our interest lies is on the sentential connective or. Alright, and then in the third example, example number 3, if y is less than 20, then y is less than 21. If y is less than 20, then y is less than, right, y is less than less than 21. Okay, if you look at this very well, you find out that our interest here is on the if, okay, the if statement, and then the then statement, which make up the if then statement. All right, and then on the fourth example, we take this illustration, the angles of a triangle, the angles of a triangle, the angles of a triangle ABC are equal if and only if and only if the sides of the triangle ABC are equal to. Alright, you find out that the syntaxial connective here used here is the if and only if. Okay, these are our interests. So from the example above, you find out that syntaxial connectives are used to join two sentences, to join two statements, so that they could have a wider range of understanding. We will make distinctive differentiation between these connective synthetic connectives. The ones used in the example 1 above, the synthetic connective used in the example 1 above, that is in example 1 above, okay, the sentential connective used there was the and. Okay, the and, it is called the conjunction, or what we call the conjunctive statement. So you can as well refer to the and as a conjunctive sentential connective. Alright, but in example 2, like we treated previously, the sentential connective used there is called the either. It's the or. Okay, it is the or sentential connective. Is used, you know, and in the class of the or sentential connective, you have sentential connectives like or, either, and others. And so it is also called the disjunctive sentential connective. All right, and then in example 3, like we had above, the sentential connective used there is the if then. If it had to be in your computer language or computer programming, we call it the if then else statement. All right, depending on the computer language you are operating on, the machine language you are using to write your programs. And so in statement 3, we use the if then else sentential connective. Okay, the if then, you would observe the dotted lines between if and then, meaning that a statement follows if it doesn't hold for the other one, or if it holds for the other sentence, for the other statement rather. The if then sentential connective was used. Okay, and it is also called the implicative statement. It is also called an implicative statement. Okay, an implicative statement. Alright, just like I said, the dotted lines will really imply that if the first statement occurs, something will imply, but if it does not occur, then the dotted line will imply the opposite. So there must be a follow-up to the first statement. And in example number 4, the if and only if sentential connective is used for that example, and it is also called the bi-conditional, or what we call the bi-implication or the bi-equivalence. Okay, it is also called the bi-conditional or bi-equivalence, or you can as well call it the bi-implicative statement. This is my I, the bi-implicative statement. Alright, so it is based on the use of these sentential connectives that we come up with logic operators and symbol. Alright, the sentential connective leads us to logic operators and symbols. Alright, the word not and the other sentential connective like and, the or, the if then, and the if and only if, they are all called logical operators. Okay, they make up what we call the logical operators. Okay, and they have their symbols denoted, the symbols that you can use to denote them. So we have the logical operators, just like I said, the and co, and then the symbols I'm going to show you. Alright, that line doesn't look straight. Okay, so don't mind the line, but all we are saying is this: under the logical operators we have the not, okay, the one we had previously, and it is represented with a wave sign, and then we have the and it is represented by an inverted V. We have the or, and it represented with a symbol that looks like V, and then we have the if then, okay, and it is represented with the arrow you can see with a double line, and then we have the if and only if and only if, which is as well represented with an arrow having double heads. We shall illustrate what we just did diagrammatically. Okay, I'll say illustratively. On the first caption you have the logic operation. Sorry, that line doesn't seem to be straight. Let me try doing something to make it look straight. Alright, anyway, it wouldn't match that. Let's use the next slide, and then I say illustratively. This is my eye. Okay, and then I make two subheadings: logic operators or logic operations. Then I carefully make my straight line. Alright, that's okay. And then on the other subheading, write representation. I hope this can serve. Alright, if you want to say not X, the not X statement, we can use the flow to denote that. We can also say X and Y, and we can use the inverted cap to denote that. We can also as well write either X or Y, either X or Y. And then we have the cap that looks like V. And then that if we want to write if X then Y, we can as well write in the form of this. We can as well write in the form of X with our arrow and then Y. And if we want to write X if and only if Y, okay, then we can write in this form Y. Alright, these are the illustrations I want to make. In summary, we have established some few key aspects and key terms that will help us throughout the use of logical operators, and the things I would like to refresh your memory on are what we call the truth value. Remember we said the truth value. Note that we said the truth value. The truth value are of two types, like we said previously, of two types. Alright, and we say that it is either, that is, it is either true, the truth, or okay, truth or represented with T, or it is false and represented with F. Okay, there is nothing like not true, not false, so it is either it's true or it is false. And then we have succeeded in mentioning the four sentential connectives, the five sentential connectives, the five sentential connectives. Okay, and they include: one, the negation, the negation or the not, represented by a flow, to the conjunction or the and. Alright, represented by an inverted cap, an inverted V, and then number 3 we have the disjunction, or what we call the or. Okay, having a symbol looking like a V. And number 4 we have the implication, and then having this as its statement, the if then statement, and then with the double lined stroke arrow. And 5 we have the by implication, though it has several names, but I'll use the by implication for the purpose of this class. Okay, with the statement, the if and only if and only if. Sorry for the omission. Alright, and having the arrow sign with 2 edges. Alright, with the help of what we have derived so far, we can construct what we call the truth tables. The truth tables. The truth tables, they are composed of the truth values. Okay, I can say that the truth table consists of truth values. Okay, and we said, and you know, the truth values are true and false. Okay, the T represents the truth, while the F represents the false. Okay, and then what we mean by negation will construct a truth table for negation. Under negation, we'll construct a truth table. Alright, if we are considering a statement X, okay, what would be the negation of X? Now, if a statement X is true, on the negation it will be what? False. For example, we take the previous examples we've had before, and I'll use example 1, that if an expression x raised to power plus 2 raised to power squared is a perfect square, and blah blah blah, and it follows just from the first example we had. And then if actually the statement is true, okay, what if x raised to power x plus 2 raised to power 2 is not a perfect square? What happens? It changes the statement, and then the truism turns to what? False. So that's the work of Fox. If he is a boy, give him biscuit, and if he's a girl, give him granules. And then if he is not a boy, okay, what happens? You will give him, then he is a girl, and then the opposite takes place. Okay, is Kunle is a boy, and if Kunle is not a boy, what happens? Kunle is a girl. So, and it means that Kunle is not a boy, and so that's what we imply here. And so if a statement is false, on the negative, on the opposite, it will be true. Alright, let's consider conjunctions. And you know that when we talk about conjunctive statements, okay, we talk about the and. We should have the and in mind. And then you know, we consider and when we have two statements, and then the and is a conjunctive statement joining the two statements to make a compound statement, like we said previously. And then it implies that we have two statements, X, and we have statement Y. Okay, and then since we have statement X, if X is true and Y is true, these are the possible outcomes we are going to check on. And then if X is true, maybe Y could be false, and then if Y is false, maybe if X is false, maybe Y could be true, and if X is false, maybe Y could be false. Okay, these are possible outcomes of these statements we will check on. And then what becomes its implication conjunctively? Okay, what becomes its implications conjunctively? That is X with inverted V and Y. What's the implication? Alright, let's find out. If a statement is true at the extreme, what happens at the other side? Alright, we'll take our example, the same example number 1. Now look and be careful about this. The expression x plus 2 raised to the power 2 is a perfect square, and x plus 2 raised to the power 2 is equal to 25 when x is equal to 3. Now if you work that out mathematically, you find out that it is true. It is true. Okay, good. It is a perfect square, because when you take the square root of 25, okay, it will give you what? 5. Alright, and then when you substitute x as 3, you have 3 plus 2 and then giving you 5 raised to the power 2, and then you have 25. Look at what we are saying, x plus 2. Okay, it becomes a perfect square. And for x, if you substitute x equal to 3, and then you have 3 plus 2, okay, all raised to the power 2, which gives you 5 raised to the power 2, which is equal to 25. And then when you take the square root of 25, you will have what? 5, which is a perfect square. So the statement is true. Okay, the statement is true for the fact that it is x plus 2, and when you substitute 3, it gives you what? A perfect square. Alright, good. But what if the statement, what if x plus 2 raised to the power 2 is a perfect square, and then when you substitute 3, it will not be equal to 25? What will happen? Will it still be a perfect square? It will not be a perfect square, and that's why you have false. Okay, and now if the expression x plus 2 raised to the power 2 is not a perfect square, and x plus 2 raised to the power 2, when you substitute 3, it gives you a perfect. Can it give you a perfect square? It's not possible, so it's false true. And then what if x plus 2 raised to the power 2 is not a perfect square, and substituting 3 into it does not give you 25 to make it a perfect square? Making the substitutions does not give you make it possible to become a perfect square. Remember, the first statement implies that it is not a perfect square, and so if it is not a perfect square, no substitution can make it a perfect square, and so the statement is true. Alright, you can see how we derived the outcomes of this particular statement for the conjunctive statement. Just keep that in mind, because we'll be using that to further our examples and then take on some more conclusions, concrete conclusions. And this time around we're talking about the biconjunctive, the implicative, or sorry, the disjunctive. You know, that's the next in line. Talking about the disjunctive statement. Right, the disjunctive statement, and you know the disjunctive statement has to do with the or statement. The or statement. All right, we'll construct the truth table for the disjunctive statement. For the disjunctive statement too, we will have two statements, they are being guided by the disjunctive statement, the sentential connective called the or. And so we have two statements, okay, that one holds or the other will hold. All right, and then the possible outcomes are, it's either the two statements are true, or one is true, the other one is false, that one is false while the other one is true, and then or that one is false or the both of them are false. Okay, and then the outcome will be what happens when the two statements combines disjunctively. Okay, and we represent disjuncts with the symbol that looks like a V. Alright, we shall take our illustrations from the previous examples too, where we said that either Adamu works hard at his book or he will fail the examination. Either Adamu works hard on his books or he will fail the examination. And if Adamu works hard, he will pass. Okay, that means the two statements, it is true that if Adamu works hard, he will pass. If Adamu doesn't work hard, what happens? He will fail. Does it hold? Good. There will be no way if Adamu works hard and then he will fail. This is false. Alright, and then what happens to this other one? If Adamu works hard, sorry, alright, that's the disjunctive statement. This is true and this is false too. This is false. So we'll go through that again using another illustration. Alright, we might use this illustration. Okay, two persons are walking on the road, or let me say are walking on the street. Okay, it is either the both of them, it is either one is a man or one and the other is a man too. Okay, that's true, it's possible. It is either one is a man and the other is a female. That's true, it applies here. It is either one is a female and the other is a male. It applies here too. Okay, it is either it is nobody at all. Alright, this cannot work, and so it's false on this part. I hope you get that down well. Whatsoever happens, this is the outcome for combining these possibilities disjunctively. I'm only using these illustrations to drive them down well. Okay, you might have other ways of making it more explanatory to yourself. And then the next one we'll talk about is the implicative statement. The implicative statement. Okay, the implicative statement, or what we call the one that has always been represented by the if then statement, by the if then statement. All right, the implicative statement. And then there are two statements all together being joined by the implicative statement. There that if x then y, and or if y then x, and then it follows this way: x like we had previously, and then y. Okay, let me make my y look better. And then the possible outcomes of combining these operations: you have true, you have false, and then you have false, and then you have true. Sorry, okay, that's okay too. And then the last line I'll make it false and true. All right, that will lead to the outcome is what happens when they combine implicatively. What would the outcome be? Let's find out. Alright, we still use our example, the one that says that if y is less than 20, then y is less than 21. And that is true, because the first statement holds, and then the second statement holds too, and then the whole statement is true. Okay, but if y is less than 20, and then y is not less than 21, is it possible? Is it possible that y is less than 20 but y is not less than 21? It's not possible, so this becomes false. Alright, so if it doesn't hold for the first, if it doesn't hold for the second, then the whole statement is false. So what if y is not less than 20, then y is not less than 21? It's possible, so it's true. What if y is less than 20, and then y if not is not less than 20 but y is less than 21? It's possible, because y could be 20.5, 20.6, and then these numbers are still less than 21, so it's true. Alright, so these are the possible outcomes we have in our implicative statements when you combine two implicative statements. And then the last part we'll be talking about is the bi-implicative statement. The bi-implicative. The bi-implicative statement. The bi-implicative statement. Alright, just like we had previously from the last example where we derived the bi-implicative statement, where we said that the angles of a triangle ABC are equal if and only if the sides of the triangle are equal too. So it's also an implicative statement, but then it's a two-way implicative statement, because if it holds for x, then it holds for y, and then it means that if it doesn't hold for x, it can't hold for y, and if it doesn't hold for y, it can't hold for x. Alright, so we consider the bi-implicative statement. It is also consisted of two statements. You can say x and y. You can say x and y, and then we have like before, it's either both statements are true, it's either one statement is not true and the other is false, is true, and the other, it's either one statement is false and the other is true, and it's either both statements are false. Alright, so what would be the by implication of having these options, of having these combinations? Okay, alright, if all the sides of the triangle, of an equilateral triangle, is equal, sure, the angles guiding the sides will be equal, so it's a true statement. And so what happens if all the sides are equal and the angles are not equal? Then the triangle is either not an equilateral triangle. What if the sides are not equal but the angles are equal? Then it is still not an equilateral triangle, so it's not true. And so what if the angles are not equal and the sides are not equal? Then it is confirmed that it is not an equilateral triangle, because both the two properties did not hold, and then it follows that it is not an equilateral triangle, so it's established here. Alright, so all I'm after here is just for you to know that when truth compares with truth, when truth compares with, to establish the tables for the five conjunctive sentential conjunctions, and so we use them to construct truth tables for other implications. Alright, without wasting your time, I'll take on an example, say example 1, and it says construct the table, the truth table, for x, and then when you see v, you know it's x or y, and then when you see the inverted v, you know it's and then you have y, which implies negation z. Alright, so we can solve this, but look at what you have to note. What you have to note that is very important here is this. Note that here we have prime statements. Prime statements are those statements that are joined together by the sentential connectives. Alright, we have prime statements x, as you can see, y and z. Hence it follows that we have 3 possible outcomes from their combination. Assuming we have x, this is for x, sorry, and then we have y, and this is our column for y, and then we have z, and this is our column for z. Okay, that does not really look very beautiful, but we can manage this. Alright, and so we'll be extracting the 3 possible outcomes that could use. It's either the 3 statements are all true, or 2 statements out of the 3 are true and 1 is false, or 1 statement is true and 2 are false, or 2 statements, the first and second and the last statements are true while the second statement is false. Okay, or that the first statement is false and the second and the third statements are true, or that the first statement is false and then the second is true and then the third is false too. Sorry, don't mind this. Or we can as well say that the first statement is false, the second statement is false, and the third is true. Alright, we can use that illustration too. I extend my lines so they can accommodate more values here, statements here. Alright, so I can say the first is false, the second is false, and the third is true, or all the statements are false. Alright, so we can as well represent other things we can find on the equation. Represent other things we can find on the equation. Alright, like where we have at this point we have negation of z. You know, let's try to represent negation z here to ease the logical comparison for us. And so what's its negation of z? Wherever you have truth on the negation, it becomes false, and wherever you have false on the negation, it becomes truth. And so that means all the truth on z on the negation becomes false, while all the false on the negation becomes true, right? And then this becomes false, and then this becomes true. Okay, so the next thing we have to do is to find x or y. You know what we have here, x or y. Okay, and then what happens if it were to be x or y? X that's our x, and that's our y. Okay, true and true, x and y becomes true. All right, let me go back where we have the or property. Okay, you find out that when it is true and true, it is true on the outcome. When it is true and false, it is true on the outcome. When it is false and true, it is true on the outcome. But when it is false and false, it is false on the outcome. So the same thing happens here. And so you look at this, when it is true and true for x and y, it's also true on the second column, on the second row rather. Then when it is true and false, it is true also. When it is true and false, it is true also. And when it is false and true, it is true. When it is false and true, it is true. When it is false and false, it is false. And when it is false and false, it is false. All right, we've done that. And then let's find out what happens on x implies to negative z. All right, let's construct the truth table for this. Okay, now what happens to y negative z? Okay, all right, we'll go back to our implication. On our implication, you find out that when it is t true and true, the outcome is true. And when it is true and false, the outcome is false. And when it is false and false, the outcome is true. And when it is false for this first statement and true for the second statement, the outcome is true. So we apply the same here. And what happens here for y and negative z? We are considering this row, and the negation, this. All right, so when it is true and false, what happens? When it is true for the statement and false for the second statement, it is false. And when it is true for the first and true for the second, it is true. And when it is false for the first, it holds for the second, so it is true. And when it is false and false, it is true. And when it is true for the first statement and false for the second statement, it is false. And when it is true and true, it is true. And when it is false and false, it is true. When it is false and true for the second statement, the outcome is true. All right, so at this point we'll have to determine the equation itself. Okay, what happens to the two of these? Negative z. All right, let's see what happens. Okay, you know this sign is the sign for the and. Is that right? Yeah, it's the sign for the and. So we take a look of what happens to the and statement, the conjunctive statement, and then we find out that when it is true for the two statement, the outcome is true. When it is true and false, the outcome is false. When it is false and true, the outcome is false. And when it is false and false, the outcome is true. And so we go back and apply those principles here. And so look at this. Okay, so for these two, true and false, what happens on the and? It is false. For true and true, it is true. For true and true, it is true. For true and true, it is true. For true and false, it is false. For true and true, it is true. And then for false and true, it is false. And for false and true, it is false. All right, so we've succeeded in building the truth table. All right, this is the truth table for this statement. This is the truth table for that statement. All right, we'll take one more example and then we'll round up the class. There are other concepts you will encounter, but not for this level. For higher levels, you will encounter other concepts on logical reasoning. But be sure that whatever concept you encounter, I have given you the basics for resolving logical operations and logical tables. All right, for our second example, say example 2. say construct the truth table. Construct the truth table for the following statement. Alright, and the first statement we have here is A implies that A implies B in a bracket. Okay, and then for II you have that in a bracket A implies B or C, and A or negation of B. Alright, so we start with solution A. Start with solution A, or that is solution I. Okay, and then you have to note as usual that we have two prime statements here. We have two prime statements. That is, they are A and B. Alright, and so we have to find out the possible combination of the outcomes of combining the two of them, A and B. Alright, if the first statement is true, the second statement might be true, and if the first statement becomes true, the second statement might be false. The first statement might even be false, and the second might be true. Okay, or the both statements might be false. Alright, so how do we resolve? We first start with the one in the bracket. Everything just works like it's a board mouse we are working on, and so we have to try to get the brackets of first, finding the relationship this. Okay, and I would like to go back to the truth table, because you'll be referencing it on the implicative statement, because that's the symbol we have there. And then I would like to remind you that when it is true and true, it is true on the outcome. When it is true and false, it is false on the outcome. When it is false and false, it is true, and when it is false and true, it is true. And then I go back, reminded you, and then it means that if it is true and true, then it's true. If it is true and false, then it is false. And if it is false and true, then it is true. And if it is false and false, it is true. Alright, so we have to get this statement itself well done, you know, including this and this. So we find out the relationship that exists there. Okay, so this is our A, and this is the outcome for this. So we're combining A and the whole of this bracket under implication. And under implication, when it's true and true, it is true. Under implication, when it's true and false, it is false. And under implication, when it is false and true, it is true. Under implication, when it is false and true, it is true. And so this is what we have as the truth table for this expression, for the first expression A. Alright, we try to find the solution for the second part of the equation, solution 2. Alright, solution II, and you find out that here we have three prime statements. Okay, A, B, and C. and so we have to construct a table in the form of having A, and then we have B, and then we have C. Alright, and remember what happens to the outcomes through true and true. Okay, it could be true, true, and false. It could as well be true, false, and false. Alright, and then it could be true, false, and then true, false, and true. Alright, it could be false, true, and false. False, true, and false. Alright, it could as well be false, true, true, false, true, and true, false, false, and true. Alright, and then the last one that follows intuitively, you have the false, false, and false. Okay, so we kick off by finding the negative of B. Negative B. Sorry, the equation is not on this page, but I'll go back so you see the equation. Alright, so we'll find out the negative of B because it's in this equation. So, and then what is negative B? Wherever you have true, it turns to false, and wherever you have false, it turns to true. And so the first true becomes false, second true becomes false, third false is true, this is true, and this is false, and this is false, and this is true, and this is true. Alright, the next column we have, I still extend this, and the next column we have B or C. We have B or C. Alright, and so you know what happens on B or C. Let me take you back so you see the or statement. It is true when it is true and true, it is true when it is true and false, it is true when it is true and false, and it's false when it's false and false. Okay, so let's go back so you know what to do. And so when it's true and true, it is true. When it is true and false, it is true. When it is false and false, that's the only condition that makes it false. It is true for this, 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 and it is false for this because it is false and false. And then the next line follows this. A will include A implies B or C. Okay, why we are taking it bit by bit this way is because from the equation itself we have A implying this, so we cannot just do this directly, so we have to start from this point and then do the whole. Alright, okay, and so you know what happens when you have implicative statement. It is true for true, yes it is. If it is true and false, it is false. If it is false and false, it is true. If it's false and true, it is true. So we go back and apply that, and then you have that on A implying B or C, this is A and this is B or C outcome. And then if it's true and true, it is true. If it's true and true, it is true again. If it is true and false, what happens here? If it's true and false, it is false. If it is true and true, it is true. if it is false and true, it is true. If it is false and true, it is true. And then if it is false and true again, it is true. And if it is false and false, what happens? It is true. Okay, so we go over to the next line. What is the next thing on the question? All right, so we have to establish this. Have we established this? I think so. I think we've established. Okay, we've not really established that. All right, so let's establish the relationship on the equation A or negation B. A or negation B. All right, for A or negation B, we use, this is our A and this is our negation B. And then what is the property of the OR statement? The OR statement states that if it is true and true, it's true. If it's true and false, it's true. If it is false and true, it's true. It is only false when it is false and false. So we go back and apply that on this page. And so we have a negation B, true and false, is true. If it is true and false, it is true too. If it is true and true, it is true. If it is true and true, it is true. If it is false and false, it is false. Now if it is false and false again, it is false. If it is false and true, it is true. If it is false and false, it is false. And so the compounded statement itself, how do we resolve it? How do we resolve the compounded statement? Here we resolve by doing this. A implies B or C, all in the brackets, and we have the outcome for this on this column. On this column here. All right, that's where you have the outcome for this. And then and A or negation B. All right, this column resolves the two of them. And how do we resolve them? We have to bear in mind that the sentential connective here is the and. Yeah, the sentential connective here is the and we'll check what happens when the sentential connective is and. Then it means that if it is true and true, it is true. True and false is false. False and true, false. And then true and true, true. And so we apply the same thing to our table here. And so when it's true and true, it is true. True and true, it is true. That is this and this. And if it is false and true, it is false. You know, the property of the and. True and true, true. True and false, you have false. True and false, you have false. And if it's true and true, it's true on this point. And if it is true and false, it is false. All right, this gives us the truth table. It gives us the truth table for the statement. The statement that that A is implicative to B or C, and A or negative B. All right, this resolves this. Thank you for being part of the class. Do have a nice day. Thank you. Bye.